Welcome back, kiddos. So it turned out to be difficult to get that indicated in properly. You can see the last attempt that I did there, and that would have worked if I didn't already start cutting with the boring bar. So what I resorted to was put it back in the mill, indicate it in just like the original when I put determine the offset location, and so I was able to indicate in like original. One of the other things you have to do is you have to pick up, in this case we had bolt holes, so that worked out good for that, so that everything is exactly the way it was when we did the offset. So then once I determined that, I got the center of this center hub. Then I moved over the offset like before, and then to true up the hole, I used the boring bar or boring head. So we're at that point now. We're like 945 thousandths. The book was 935, and the calculation was 950. So it should be good. Okay, so then. I happen to have a 1" 20 tap, Chinese made, to keep us off the lathe. I don't want to go through that again, so threading on the lathe will have to be a different time. But just like the die, this guy is metric, so it doesn't fit any of the tap holders I have. Actually, it fits one of them, but it's 4 feet long. I don't think we'll have to get into it. So I don't use this is a spring loaded, so there's a pin in there that's engaged with a center that's been put into the end of the tap, and that allows you to start turning it and to keep spring pressure to help keep the tap aligned. I would say that's the least preferential method. A lot of people use it, but to me it's not rigid enough. Actually, I'll show you this real quick. I really like this system. So this goes in a collet into the quill. Then this engages, and then you turn it. That way you don't have to worry about any movement. And I have a size that's just shy of this. They do make a bigger size now, but I don't have that one here. I do have it at work. I had them buy all 4 of them. So anyways, so what we're going to try is hopefully use a wrench to do it. I'm terrible at this stuff. My main preference is to put it in and drive it with the mill, but I don't trust the tap. And I don't want to wipe out the part. So we'll throw some oil on. Whoa, high pressure. So let's see how it goes. So I like to keep some downward pressure. The spring is supposed to do that, but I want to make sure. Sounds good, feels good, looks good. I had the stop set for the boring head. And again, this if you have a Bridgeport head or another geared head or whatever, they use the guts that are in there, and it needs to get redone. This Acer E head is awesome. I mean, I can't say enough about it. When you shut it off, it stops right away, which is has its own pluses. The funny part is if you hit the E-stop, it doesn't start right away because it kills the power to everything and it uses an electric brake. A little bit of an oversight there, I would think. But like for the boring head, I wanted, it seemed like 430 RPM or whatever was good. That's too much in low range. It's too low in high range on a regular head. But in this one, leave it high, I can go all the way down to 0 if I don't need that torque advantage. And since I'm just using a boring head that's single point cutting, that worked perfect. And then it's smooth as glass. All these are smooth as glass the way they work. I know there's a million adjustments you can do to the Bridgeports. You can buy the replacement parts, you can rebuild them, you can do whatever you want with them, but in half a day you can swap one of these heads out and go from a clunky old worn out to something new. And I probably, I don't know, I'm not full-time here, but I mean the amount that I use this, I would say is a little bit above average, but I would think that this will last me the rest of my life. And if it doesn't, depending on what economic conditions we're in later, it'd be just worth it to swap it out again. I mean, it is kind of the economy we're building, and you gotta weigh the good with the bad. But I know there's a company that makes electronic conversions that retrofit an original Bridgeport head. Did I lock that? So remember, if you become a machinist, you can cancel your gym membership. A little more, just to make sure I'm past the taper. The tap. I'm keeping the spring-loaded point engaged. No reason to take the chance of going wonky. Now this is aluminum part. I don't want to wipe it out. And you don't make enough money doing this stuff to do it 10 times. And, you know, so this is, I guess this technically is going to be another episode of F Up, Fix Up, or whatever I called that other one. So it looks pretty in there. Let's see the mating part. Let's see, I showed you guys that. Where did I set it down? I got it. I haven't chamfered it yet, but oh yeah, the Chinese guys came through this time. Uh-oh, watch out, America. It sucks. I personally wish everything would be made in the U.S. I grew up in a small town in central New York, and you look at the houses, and at one time every 10th house was a storefront. You know, because as we came off the farms and, you know, built up our towns and villages and cities, you know, this guy started concentrating on raising chickens. This one did cows. This one did cows for beef, cows for milk. Then you had your textiles, and all that stuff should still be the same. Think about, you know, right now we're at what? 161 million people employed. And they tout that, oh, that's the most ever employed. Well, since the Trump era, we've added like 10 million people. So technically, per capita, we're 4 million jobs short of the Trump era. And the Trump era was still recovering from the crappy Obama era. We should be 180, 200 to 200 million people employed. We have 350 million people. And anyways, things would be a lot less expensive if that was the case. So, all that's good. Let's go ahead and do a countersink, or we'll use a countersink to break the edges. And for this, it doesn't matter what angle I use, but sometimes there's call outs and that. So let's see what I got that is that big. That one's a little too small. So I need one that's 1.25 inches probably. Over the years I've accumulated a whole bunch of countersinks from different buying out lots, and then what the guy had that I bought out the shop. And yeah, here's the bigger ones. And again, keep an eye on eBay for this stuff. So that's plenty big enough. But this is a 2-incher. I got this off eBay with a 3-inch, which ends up a huge jump. And I have that one at work. I've used that over there before. But, you know, it's surplus stuff, it's lightly used stuff. You know, unfortunately there's a lot of shops, especially back east, that, you know, have been closing for years. And I think I got both of those for like 75 bucks. The 3-incher alone is 800. New. They're MA Ford, which is one of the best brands for that stuff. Here in Phoenix, I call it a dry town. There's not a lot of stuff here. Lately, there seems to be some people that have retired and brought their tools with them. So I've got some of that stuff. I got my Herrig Whirligig from a retired guy, I think out of Chicago. I got a nice modular vise from another guy. I got a cylinder square from another guy. You know, the cylinder square, the thing that everybody has on their list but nobody ever uses. Should put that with the shaper. One day I'm going to use that shaper. Okay, so let's get this fired again. What I prefer to do with countersinking is I like to just touch the countersink to the part, lock the quill, and then I zeroed the table, and then I lowered the table slightly. And I like to feed the table into it. Anytime I do cutting like that, and what it seems to do is it takes out the tendency of the cutter to bounce. or chatter. Did this a lot on Inconel. Inconel, I drill all the holes, usually with feeding the table up. I did a fixture that had tons of 3/8 size holes in it, in 3D printed Inconel. With this method, I was able to just crank the handle fast, boom, you know, like that, like it was nothing, and had a little bit of squirt on it. And just as long as I had chip action, I just kept going. Because on Inconel, you got to stay in the cut, or it'll get hard on you. So when you get into different hole sizes, I went 15 thousandths. And in general, if it was a smaller hole, you would only go 2 or 3 thousandths. If it was a bigger hole, you go like 20 thousandths to get a chamfer. And that's pretty good. There is still a burr, so I'll take it another 5. So I just did the touch off again, back off the table slightly, come back up, and then take it to 5 extra thou. Actually, I'm going to do a total 18 thou, because I don't think it needs the 20. And let it dwell for a minute, a moment. Groovy. Okay, so that's pretty much done. This is when I would want to use the blowgun, but the air compressor's not on. I'm hired! Okay, so there is the result, and you already saw these two go together. I gotta clean that out. But they go together nice, and then I'll hand deburr the backside. But you see, nice chamfer, nice lead in. Okay, so we had another save. It was a project. There was an hour between when I did this video and the other one. I get tired during the day. I don't know. You get worn out pretty easy these days. But another save, and that's 6 parts. I made 6 parts for this thing. I reached out to the customer already to have them come by so we can check whatever needs to get checked, and hopefully everything is what he needed. This will be done. And I have a very similar project next. Okay, thanks a lot.